All right, perfect. All right, so today we're talking about, what is it called? Triangle. Did it say triangle inequality? No, just triangle theorems, right? Triangle theorems. Okay. All right, so in the margin, we're going to take a look at the first theorem, and it's going to be mid-segment. Mid-segment. All right, now when you hear mid, what do you think? Middle. Okay, so you think middle. So mid-segment is actually middle. So what I want you to put right here on your notes is middle segment, middle segment in triangle, middle segment in triangle is half of the segment. Middle segment in triangle is half of the segment, and you'll notice I always use abbreviations. All right, so let's take a look at an example as what that looks like. So example 1, you're going to draw a triangle, and mid-segment is the middle. Okay, so it's going to be in the middle of these two lines, so about there, middle of those, about there. Join those two, that's the middle. All right, if it's the middle, this is equal to this, and this is equal to this. All right, I don't put them all as one ticks because it doesn't tell you that that is equal to that. Okay? All right, now if you're given that this segment is 20, what's the middle? 10, okay? And all you did to get from 20 to 10 is you divided by 2 because it's the middle, it's half of it. So 20 divided by 2 equals 10, and that gives me my mid-segment. Let's take a look at another example. So example 2. All right, go ahead and draw a triangle. Go ahead and do the middle thing again. So that's equal to that, that's equal to that. And this time, instead of me being given the segment, let's say they give me the middle. They give me the mid-segment, and they say that the mid-segment is 5. Okay, what is this then?
It'll be 10.
It'll be 10. All right, and all you did, again, was you said 2 times 5 because this one is twice as big as the middle. So 2 times 5 equals 10. Okay, next one is going to be angle side relationships. And what you need to know about this is that it is always opposite. It is always opposite. So it's always opposite. And I'll tell you what, I'll go over what that means. It's always opposite. All right, so we'll take a look at an example. So example 1 for angle side relationships. Example 1, draw me a triangle. All right, let's say the angle was 50 and then 41. What would this one have to be in order for it to be a triangle? 50 plus 41 is 91, so 180 minus 91 is 89, right? That would have to be 89. All right, and the question is find sides from least to greatest. Find the sides from least to greatest. All right, so it's really simple what you do. If you're finding from least to greatest, you're going to find the smallest angle. What's the smallest angle between the three that you have? 41. So this is the smallest angle, and remember it's always opposite. So you're going to go opposite 41, and that's going to be your smallest side. Let's go ahead and label this. So let's say this is A, B, and C. So if this is your smallest angle, this will be your smallest side. All right. Now I want you to do it, give it to me in alphabetical order. It's a side. So what is the smallest side? Right opposite, right? This line. So this line is what? How would you describe this line?
BC.
BC. So your smallest is BC. Then the one that's in the middle is going to be the angle that's in the middle. And what's the angle in the middle? The angle in the middle. In terms, when I say middle, I don't mean in the middle of the page. I mean the second smallest angle. Angle C. A is 41, it's the smallest. 50 is the middle, is the second smallest. This is the largest. So the one right after the smallest would be 50. So again, go directly opposite. So you go directly opposite, and then tell me what that line is. In alphabetical order, it's A, B. And then finally, your largest one. Okay, the largest angle is going to be 89. You're going to go directly opposite that. So my green arrow. And that's going to be AC. So let's take a look at another example. So example 2 for angle side relationships. Draw me another triangle. Let's say this triangle is CDE or something. All right, now instead of being given angles this time, let's say you're given sides. So let's say CE is 10. CD is 11, and DE is 15. And now the question is, find the angles. So we found the sides, but this time is find the angles from smallest to greatest. Find the angles from smallest to greatest. So again, you find the smallest side. What's the smallest side? 10. Then you're going to go directly opposite. So here's my arrow, directly opposite. What's the angle?
DC.
It's going to be D. D is the smallest. Angle D, right? And then what's the second smallest side? 11. Draw an arrow going directly opposite. What angle are you going to hit? E. So that's going to be your second smallest. And then your largest is going to be find your largest side, which is 15. Draw an arrow directly opposite. What are you going to hit? C. So from smallest to largest is going to be DEC. All right, so the next one we're going to take a look at is, and I don't know, I'm not going to really have space, so I'm going to go to the next page. All right, so I'm going to go to the next page, and I'm going to write on the back of the next page. All right, so my title is Triangle Inequality Theorem, so I'm going to write it here in the margin. Triangle Inequality Theorem. Triangle Inequality Theorem. All right, and triangle inequality theorem, for your notes, all you're going to do is you're going to say arrange All right, so actually I'm gonna do this. Triangle inequality theorem. You're going to arrange sides from least to greatest. Then check if A plus B is bigger or is greater than C for it to be a triangle. So example 1, can 25, 10, and 15 be a triangle? So arrange it from least to greatest. So it's going to go 10, 15, 25. And then what you want to check is that when you add the two smallest, it's going to be bigger than the longest, C. So in other words, when I add 10 plus 15, is it bigger than 25? Well, 10 plus 15 is what? 25. Is that bigger than 25? No. So no, it's not a triangle. All right, example 2. Can 17, 18, and 16 be a triangle? So again, from least to greatest. So 16, 17, 18. And remember, when you add the two shortest side, is it bigger than the longest? So when I add the two smallest, is it bigger than the longest? 16 plus 17 is 34 or 35? 33, sorry. 33. Is 33 bigger than 18?
Yes.
Yes. So yes, it's a triangle. All right, so the last one is going to be exterior angle theorem. All right, and in the notes section, all you're going to write exterior angle theorem of a triangle is equal to the sum of the interior angles that are not right next to it, So example 1. Here's a triangle. Okay, let's just extend one of the lines. And let's say they gave you that this is 60, this is 50, and the question is, what is this? All right, so again, before you would just do 60 plus 50 is 110. 180 minus 110 is going to give you 70. And then linear pair, 180 minus 70 is 110. But the exterior angle theorem is really a lot simpler. What it says is your two inside angles, the sum of them, when you add the two interior angles that are not right next to that question mark, so not this one, but the two that are inside but not right next to it, when you add them up, they're going to give you that. So question mark is really 50 plus 60 equals a question mark, which is 110. All right, final example. Example 2 for exterior angle sum. Again, triangle. Let me put the exterior angle here. This time, let me say that they gave me the exterior, which is 120. This one is 10. And they wanted me to find this one. Okay, the process is still the same. This plus this is going to give you the outside. The two inside that are not next to it, I'll add it together, going to give you 120. So 10 plus what I don't know, question mark, is going to be 120. So I will subtract 10 to both sides. And I'm going to get question mark equals 110. Okay, I'm going to put 110 here. And then I'm going to check it. This plus this has to give you this. 110 plus 10 equals 120. And that's it.